In this video, you'll learn the basics of React hooks and how to use the Hooks API to build more efficient apps. My name's Larry, and this is Digital Logic. In order to follow along with this video, you need to have a development environment set up, Node installed, and access to an IDE. You should also know how to create a React app and what JSX is. If you're unfamiliar with any of this, then check out the previous video in the series. A link is in the description below. I'll start by creating a new app, and I'll call it Hooks. IntelliJ is simply executing npx create React app, so nothing special is going on here. It will take a minute or two to set up your project. Then run npm start to get the development server up and running, either by going through the package.js file or running it through the command line. In your browser, press F12 to open up the developer tools, and then open the React component tools. Click on the gear icon, and in the General tab, make sure that highlight updates when components render is checked. Back in your IDE, open up the app.js file, and then remove everything within the header tag. And remove the import for the logo. Create a new functional component named counter, and return a JSX object. And wrap the component in a div. You could use a React fragment component if you want to, just make sure to import React for this to work. Or use the shorthand syntax, which is just a pair of empty angle brackets, whichever you prefer. There will be a slight difference in the way it looks if you use the fragment component because of the existing styles applied to the header element, so I'll stick with the div. Add an h3 tag with the text counter, and a p tag with a static value of 0, and then a button element with the text increment. Add the counter component to the app, and then I'll format the code. In order to maintain a count within the counter component, we need to store the value in a variable. But we can't just define a new variable within the counter component, because any variable we define will be destroyed once the function returns a JSX object. This is where the Hooks API comes in. To create a state variable, define a constant and destructure an array. The first value is our state object. The second value is a setter function, which I'll call setCount. Set it equal to useState and make sure to include the import from React. Right now the state value is undefined. To define an initial value, pass it into useState. You can also pass in a function to useState, which will lazily initialize the state value. This is useful if the state value is the result of a more expensive computation. In this instance, it's unneeded. Modify the JSX to use the count state variable. And now we'll set up an event handler to increment the count. Create a new constant, handle increment, and set it equal to a new function. Then call setCount, count plus 1. Add the event handler to the button component. Save the file, and let's check out the results in the browser. Click on the counter component so we can view its internal state, and then click on the increment button to verify that the counter works. And then go back to your IDE. Now in this case, we can't directly modify the count variable because it's a primitive value assigned to a constant. But if I were to change count to an object, then nothing can stop me from modifying the value directly. However, doing this will break the app. When we call a setState function, React will look at the current state value and the new one and update the state if needed. Then the component will be flagged for re-rendering. If you modify a state value directly, React would not be aware of the modification, so the component would not get re-rendered, and any hooks that depend on the state value may not function properly. A component state value should always be treated as an immutable object that cannot be modified directly. Notice that when I click on the increment button, the component does not update, but the value printed to the console continues to increment. Even though the internal state value has changed, React is not aware of this. Now it is possible to force React to re-render so the view matches the internal state, but it will still break other things, so it's not something you should do. So I'll go ahead and undo all those changes I just made so the counter component is back to the way it was. What do you think would happen if I were to duplicate the call to setCount? Save the file and check out the results in the browser. When I click on the increment button, the counter increments by 1 instead of 2. Why is that? The reason this doesn't work the way you might expect is because when the setCount function is invoked inside of an event handler, it always executes asynchronously. React may also batch multiple updates together to improve performance. That means that both setCount statements will be executed before the internal state variable is updated. But even if the setCount function executed synchronously, it wouldn't make a difference in this case, because the count variable is just a copy of the component's internal state, because primitive values are copied by value, not by reference. So this copy will never be updated. In order to get an updated value, we'd have to wait for React to re-render the component, at which point React will execute the count function and call useState to retrieve the updated state value. So how do we fix this problem? Anytime you want to modify a component state value, and the new value is based on the previous value and state, it's better to pass in a function to the setter. The first parameter is the current state value, and then return the new state value from this function. Duplicate this statement, save the file, and check out the results in the browser. Now when I click on the increment button, the count increments by 2 and not 1. As you've seen earlier, you can define a state variable as an object. So I'll create a new constant, destructure the array, and then destructure the state object into 2 new variables, count and message. And I'll name the setter function setState. Set it equal to useState. Pass in a new object with a count key set to 0 and a message key set to hello. Comment out the previous useState line, and by the way, you can use the useState hook multiple times in a single component, and this is quite common. Modify the handle increment function, and instead of calling setCount, change it to setState. And then pass in a new object with a count key and increase its value by 1. And then modify the component's JSX to display the message to the user. Save the file and check out the results in the browser. Click on the counter component within the developer tools so that we can view its internal state. And notice when I click on the increment button, the message disappears. Unlike class-based components, the setState function from the useState hook does not perform a shallow merge with the state object. So you have to make sure to do it yourself. In this case, I'll just add the message variable as a key value pair within the setState function. Save the file and check out the results in the browser. When I click on the increment button, the component works as expected. Even though this solution does work, it could introduce a bug into our component. If more than one method is used to modify the state object could be corrupted with stale data. This can happen anytime we modify state and rely on lexical scoping to retrieve the current state value. For example, if I create an update message function, and then call setState, and then pass in a new object. Update the message to hello world, and then pass in the current count. If both the handle increment and update message functions are batched together in the same update, one will override the other. The simple solution to avoid this is to pass in a function which will provide the current state as the first parameter and avoid relying on lexical scoping to resolve the state value within a setter function. From this function, we have to return a new object to replace the current state value. I'll use the spread operator to expand all of the enumerable properties of the state object into a new object, and then override the count key with the new value. Of course, you have to do the same thing to the update message function to completely resolve the potential problem. Now, the likelihood of both the handle increment and update message functions getting batched together is probably pretty low. During development, it would probably never be noticed, but in production, where you have thousands of users interacting with this app, that's a different story. So I'll remove all of the changes that I've made to the counter component so it's back to the way it was before. And update the handle increment function. For now, I'm going to rely on lexical scoping to increment the count variable. Now let's review what is going on within this component. Every time this component renders, React executes the counter function. We call useState to retrieve the current state value. Then we create a new function and assign it to the variable handle increment. We then assign this new function to the onClick event listener on the button component. This happens every time the component renders, which will be any time the component's props or state change, or a parent component re-renders. The important part here is that every time the component renders, we get a new handle increment function, even though the code within the function never changes. Each function instance is unique and they are not equal to each other. That means every time the component renders, we also update the button's onClick event listener to a new handle increment function. This is not an overly expensive process, but it does put more work on the browser, since every time the component renders, the browser has to unregister the old event listener and then register the new event listener. We can avoid this by using the use callback hook. Make sure to add the import at the top of the file. The first parameter to the use callback hook is the callback function. The second parameter is an array of dependencies. For now, I'll leave this as an empty array. Save the file, and let's check out the results in the browser. Click on the counter component in the developer tools, and you'll notice that this component has a callback hook. Now click on the increment button, and the counter increments as expected. But when I click on the increment button a second time, nothing happens. You can click on the button as many times as you want, but nothing is going to change. So what's going on here? When the handle increment function is created, it creates what is called a closure. A closure describes how a function remains bound to the variable environment that it was created in. So when this function is called, it uses lexical scoping to resolve the value of the count variable, which on the initial render of this component is 0. For this instance of this function, the count variable will always equal 0, regardless of the current value and state. The use callback hook takes this function and stores a reference to it in global memory. On sequential calls, it will return the same function instance. The second parameter allows us to define an array of dependencies, which will control how frequently the callback function is updated. Use callback will take the dependency array and diff the items with the items in the currently stored dependency array. If the items inside the array are the same, then it'll discard the new function and return the stored function. If they're different, then use callback will update the stored function to the new function and return the new function as our callback. Because we passed in an empty array, use callback will always return the function that was defined on the initial rendering of the component, and it will never update the callback function. And because this function creates a closure over the count variable, every time this function is executed, it will attempt to set the count to 1. The simple solution is to add the count variable to the dependency array. Now whenever the count increases, use callback will update the stored function with the new function. Save the file, and verify that it works. Now this does bring up an important question. What have we gained by using the use callback hook? A component will re-render anytime its props or state change, or if the parent component is re-rendered. We're not going to worry if the parent component triggers a re-render right now. That has more to do with application design. This component doesn't have any props, so we don't have to worry about that either. So all that is left is state. When the component state changes, the component will be scheduled to be re-rendered. During the render process, useCallback is called and we pass it a new function and a new dependency array with the current count value in it. UseCallback diffs the currently stored dependency array with the new one, and since the count has changed, updates the stored callback and dependency array, and then returns the new callback function. The browser then unregisters the old onClick event listener on the button component and registers the new event listener. So we haven't actually gained anything. In fact, all we've done is add more work to the rendering process. Without useCallback, we would still create a new handle increment function on every render and update the event listener on the button component. But with the useCallback hook, we've managed to add several extra steps to this process without actually gaining anything. And this is the point. There's a cost associated to all optimizations, and you have to determine if the cost of the optimization is worth it. In this case, it just isn't. But if I were to modify the call to set count by passing in a function to increment the count, then remove the count variable from the dependency array, since we no longer rely on lexical scoping to retrieve the current count value, now is it worth using the useCallback hook? Well, let's review what will happen after the initial render. When the component re-renders, we call useCallback and pass it a new function, with an empty array as the dependency array. Because the dependency array is empty, useCallback will throw away the new function and return the original function created on the initial render. This is the same function that is currently assigned to the onClick event listener on the button component, so nothing needs to be updated. So in this case, it is worth it. Try to use the useCallback hook when it actually results in less work. If it doesn't affect the frequency that an event listener will be updated, then don't bother with it. And finally, the useCallback hook will not prevent a child component from re-rendering, at least not by itself. And you'll see that in the next example. For the next example, we're going to build a basic login component. So create a new input component and destructure the props object. Define a label property, a name property, a value property, an onChange event handler, and then a type property with the default value of text. Return a JSX object and wrap the component in a div. And add a p tag for the input element's label. Create a native input element and add the name parameter, a value parameter, the onChange event listener, the type parameter, and turn autocompletion off. And that is it for the input component. Next, create a button component and destructure the props property. We'll need the children property and the type property with the default value set to button. Then return a native button component, pass in the type property, set the button's text to the children property. And now let's create a form component. Destructure the props parameter, add a property for the onSubmit event handler, and the children property. Return a JSX object, add a native form element, and then assign the onSubmit handler. And assign the children as the form element's children. Now we'll create our login component. This component won't require any properties, so we can leave that blank. In React, input elements can be controlled or uncontrolled. The difference is whether or not React manages the input element state. If React manages its internal state, then it's a controlled element. Otherwise, it's uncontrolled. Most of the time, input elements are going to be controlled. It makes it easier to access its current value and perform validation. In order to manage the input element's current state, we're going to need to create a state variable to store its value. So create a new constant and destructure the array. So I'm going to create an object that has two keys and destructure it into a username and password variables. We could split this up into two separate state variables, but that would involve calling useState twice, and this solution will be simpler anyway. Call the setter function setUser equals useState, and then pass in a new object with a username and password keys, both set to empty strings. Return a JSX object, and wrap the component in a div. Add an H3 tag with the text login. Add the form component that we just created, and then add an input element. Set the label property to the text username. Set the name property to the string username, and make sure that the name field matches the username key in our state object. Set the value to the username state variable. And that is it for now. Create a second input component. Set the label to the text password, the name to the text password, the value to the password state variable, and the type to password, which I forgot to do when I recorded this video. Now create a button and set the type to submit. And set the text to login. Remove the counter component and replace it with the login component. When the user enters text into one of the input elements, it should update the internal state of this component. In order for that to happen, we need to create an onChange event handler, and I would like to have a single event handler work for both input elements. So create a new constant, handle input, and set it equal to useCallback. Pass in a new function with a single parameter e. And then call setUser and pass in a function with the parameter user, which will then return a new object. Spread the enumerable properties of the user object into this new object. Now we just need to override one of the user properties, but which one? This is where the event will help us out. Within square brackets, access the property e.target.name. Remember the name property that we defined on our input elements. That property will tell us which key to override in the user object. So make sure that the name property matches the key within the user object. Otherwise, we'll just define a new key value pair within the user object. Set the value of this property to e.target.value. Because we are not relying on lexical scoping to resolve any variables in our callback function, pass in an empty array as the dependency array. Now add the event handler to both input elements. Save the file and check out the results. And clear the console log, and then refresh the browser. Then click on the login component so we can view its internal state. And then add some text to the username field and the password field to make sure that they're both working correctly. If I were to click on the login button, the form would submit the data through a GET request, passing the data in as query parameters. That's not what I want, so back in IntelliJ, I'll create a new constant named handleSubmit. And this time I'm not going to use the useCallback hook. Set it equal to a new function with the event parameter. To prevent the browser from submitting the data, call e.preventDefault. In a real application, the next step would be to send the user data to a backend API, but for this solution, I'll just console log the user info. This is the backtick character, which is right above the tab key, and is used to define a template literal. The $ and curly bracket syntax allows us to define an expression within our template literal. So all we're doing here is printing out the username and password fields. Add the handle_submit handler to the form component. You may be wondering why I didn't use the use callback hook with this function. The handle_submit function uses lexical scoping to resolve the username and password fields. So even if we use the use callback hook, this function would still have to get updated for each keystroke, so there isn't any real benefit to using it. Finally, we need to clear out the username and password fields when the form is submitted. So call setState and pass in a new object with the username and password keys both set to empty strings. Save the file, and let's check out the results in the browser. Add a username and password, and then hit login. The login info is printed to the console and the form fields are cleared. Perfect. Before we go back, notice that every time I enter any input into either form fields, every component within the login component gets re-rendered. This is normal behavior. When a component is flagged for re-rendering, all of its children also get re-rendered, whether they're flagged for re-rendering or not. There are ways to stop the propagation down the component tree, but that is beyond the scope of this video, and it is rarely needed. When a component gets re-rendered, React executes the component's function, which will return an object that describes how the dome should look. React takes this object and diffs it with the virtual dome. React will only update the parts of the dome that have changed. So even though every component in the login component gets re-rendered, only a few changes are committed to the dome. For this next example, create a new component named clock, and then return a JSX object. Wrap this component in a div, and then add an h3 tag with the text current time. Add a p tag, and then within curly brackets, create a new date object, and call toLocalTimeString. Remove the login component from the app and replace it with the clock component. Save the file, and let's check out the results in the browser. Our clock component displays the current time, but it is static, so let's fix that. First, create a new state variable to store the current time. I'll call it date. And set it equal to useState, and pass in a new date object as the initial value. Update the component's JSX to use the new date variable, and call toLocalTimeString. This gets us a bit closer, but we're not done yet. We need a way to update the state object every second. An easy solution would be to set up an interval and update the component state within that interval. But we can't just create a new interval inside of the component. That would result in a new interval being created every time the component renders. To implement this, we will use the useEffect hook. Make sure to include the import from React. Anytime you use an external API that is external to React, it is called a side effect. This includes fetching data, setting up subscriptions, or manually manipulating the DOM. For the first parameter, we need to define a function to perform the side effect. For now, I'll just console log creating interval. Add a call to setDate and pass in a new date object. We'll add an interval in a second, but let's see what this does first. If you check out the results in your browser, you'll notice that we're getting a lot of creating interval messages in the console. Comment out the call to setDate. Right now, the useEffect hook will execute on every render, and because we're calling setDate within the useEffect hook, we're triggering another render, kind of like creating an endless loop. We can control the frequency that the useEffect hook is invoked by defining a dependency array. With an empty array, the effect will only be applied once, when the component is mounted, which is what we want. Now create an interval, and pass in a new function, and then call setDate with a new date object. I want this to execute every second, which is 1000 milliseconds. Save the file, and check out the results in a browser. Now the component is updating every second, but we should clear the interval once it's no longer needed. First, we'll need to store the interval ID in a variable, so create a new constant, timer ID, and set it equal to setInterval. To provide cleanup code to an effect, just return a new function. Within this function, console log cleaning up. Now call clear interval and pass in the timer ID. Save the file and check out the results in the browser. Refresh the browser, and notice in the console we're getting a creating interval message, followed by cleaning up, and then another creating interval message. These messages appeared right after I refreshed the browser, so why are we getting duplicate messages? The reason is because we are running React in strict mode. Strict mode creates the app and then destroys it, and then creates it again before rendering to the browser. Strict mode may also double invoke any lifecycle methods, functional components, constructors, and hooks. Console log messages produced in a double invoked function should appear slightly dimmed if you have the React developer tools installed. Strict mode does this to break your app faster and make it easier to find problems in your code. But because of this, you can't rely on a specific number of console log messages being printed out by any component. This only happens in development. A production build will not do this. Now comment out the set interval and clear interval lines. Add a set timeout, and then pass in a function to update the state. And I want to occur in 1000 milliseconds. Pause the video and modify the effect so that the set timeout will continually update the component state. Welcome back. So what we need to do is make sure that the set timeout is set every time the date object is updated. To do that, all we need to do is add the date object to the useEffect dependency array. Save the file and check out the results in the browser. Refresh the browser and notice that we get a new set of messages every second. Let's walk through how this works. When the component is rendered, the clock function is executed. useState creates the date variable, and we call useEffect, passing in a new function and a dependency array with the current date variable. The effect function is then executed, and setTimeout scheduled an update to the component state. The component returns a JSX object and is rendered to the DOM. In 1 second, the browser will execute the function we passed to setTimeout. This will schedule an update to the component state. The component state gets updated, and the component is flagged to be re-rendered. React will execute the clock function again, call useState to retrieve the new state value, and then call useEffect, and pass in a new function and a new dependency array. useEffect will diff the dependency array with the dependency array from the last time the effect was executed. Because the date variable is a different object, useEffect will execute the new effect function, which will schedule a new timeout. Then we just repeat the same process until the end of time. If we were to compare the useEffect hook with class-based lifecycle methods, this hook can perform the component did mount, component did update, and component will unmount lifecycle methods all in one. If that wasn't enough by itself, you can use this hook multiple times within a single component, allowing you to separate application concerns, something you definitely can't do in a class-based component. Regardless of which hook you use, there are a few universal rules that you must follow. Only call hooks at the top level. That means that you cannot call a hook inside a condition, a loop, or a nested function. Hooks must be called in the same order every time. React depends on the call order to differentiate one hook from another. And only call hooks from within React components or custom hooks. There are a lot more hooks available than what I've covered in this video, and you'll see them in action later on. The hooks that I did cover are probably the most commonly used. Well, that is it for this video. If you like this video, then please like, share, subscribe. If you want to support the creation of these videos, then check out my Patreon page, a link is in the description, and I'll see you in the next video.